Hello students. In last session we have studied about hydrocarbons. The organic compounds which are mainly made up of hydrogen and carbon are called as hydrocarbons. In this session we are going to study about the classification of hydrocarbons. So let's get started. Hydrocarbons. The organic compounds which are mainly made up of hydrogen and carbon are called as hydrocarbons. The hydrocarbons are classified into two groups: saturated hydrocarbons and unsaturated hydrocarbons. Let's study them in detail. The saturated hydrocarbons are further classified as alkanes, while unsaturated hydrocarbons have two families, alkenes and alkynes. Now let us define these families of hydrocarbons. Alkanes. The saturated hydrocarbons which contain carbon to carbon single covalent bond between them, they are known as alkanes. Whereas the unsaturated hydrocarbons which contain carbon to carbon double covalent bond, they are called as alkenes. Now how will you define alkynes? Yes, the unsaturated hydrocarbons which have carbon to carbon triple covalent bond in between them, then they are called as alkynes. Now let us see the general formulas for representing each of them. The alkanes have general formula CnH2n plus 2, where n represents the number of carbon atoms. The alkenes have general formula CnH2n, and the alkynes have general formula CnH2n minus 2. Now how will you remember these three formulae? There is a trick. Alkanes formula is CnH2n plus 2. If you remove 2 from this formula, you get the formula for alkenes. It is CnH2n. Now further, if you remove 2 from this formula, means subtract 2 from this formula, you will get the formula for alkynes, CnH2n minus 2. I hope it is easy to remember. Now let us see examples of these three types of hydrocarbons. Let us first see the alkanes. Example, ethane. You can get the formula of ethane by substituting the number of carbon atoms by this letter eth. Means eth contains 2 carbon atoms. So by substituting 2 in this formula, you will get ethane has molecular formula C2H6. Now C2H6, this is the chemical formula. How can draw the structure from this? 2 carbon atoms are drawn first. Then as you know, carbon has 4 valency. So show the 4 valencies like 4 lines around the carbon. But how will you remember that it is a alkanes? For that, you need to connect these 2 carbon atoms by single covalent bond, as it is a alkanes family. Then you will find that both the carbon atoms contains 3 hydrogen atoms around each. It means 2 carbon atoms are linked with the 6 hydrogen atoms. Now let's take example of alkenes. Yes, the hydrocarbons having carbon to carbon double covalent bond between them. So ethene is the example. So in ethene there are 2 carbon atoms. Substituting the 2 in place of n, you will get the number of hydrogen atoms. It is 4. Then how can we show the structure of ethene? Yes, as we know that ethene is a member of alkene family. So 2 carbon atoms are drawn first and a double covalent bond is shown between them. As carbon has 4 valency, we have to check 4 lines around carbon. Each of these carbon have 4 lines. Now attach hydrogen atoms on both the ends of this carbon. So it is C2H4. Now let us take example of alkynes. Ethyne. Ethyne, in which there are 2 carbon atoms. Substituting n is equal to 2 in the formula, you will get the number of hydrogen atoms. So it will be 2 hydrogen atoms. Let's draw the structural formula of ethyne. First, you have to show 2 carbon atoms, and as it is the member of alkynes family, it contains carbon to carbon triple covalent bond between them. Now remaining one valency of carbon each. So you can draw one line besides each carbon atom and attach them with the hydrogen. So the formula C2H2 can be represented in the form of structure like this way. Now let's study some rules which are used to represent the names of hydrocarbons. The hydrocarbon has two parts, prefix and suffix. The prefix indicates the number of carbon atoms present in the hydrocarbons, whereas suffix helps us to identify the family of hydrocarbon, whether it is alkanes, alkenes or alkynes. Now prefix. If the hydrocarbon has one carbon atom, then the prefix is meth. If there are two carbon atoms, then prefix is eth. For 3 carbon atoms, the prefix is prop. 4 carbon atoms, prefix is but. For 5 carbon atoms, the prefix is pent. 6 carbon atoms, prefix is hex. And for 7 carbon atoms, the prefix hept. Now suffix. If the hydrocarbon belongs to alkanes family, where 2 carbon atoms are bonded with single covalent bond, then the suffix is ane, N. If the hydrocarbon belongs to alkenes family, that is carbon to carbon double covalent bonds, then the suffix is ene, ene. And if the hydrocarbon belongs to alkynes family, then it contains carbon to carbon triple covalent bond, and hence its suffix will be yne, ine. Observe this table carefully. This table will help you to understand how to write the name of the hydrocarbons using appropriate prefix and suffix. Let's see one example. If a hydrocarbon contains 2 carbon atoms, then its prefix will be eth. And if it contains carbon to carbon single covalent bond, then its suffix will be ane. So the name of hydrocarbon will be ethane. Second example. If a hydrocarbon contains 2 carbon atoms and the carbon atoms are linked with a double covalent bond, then its suffix will be ene, and hence the name of hydrocarbon will be ethene. And if the hydrocarbon has 2 carbon atoms which are linked with triple covalent bond, then its suffix will be yne. So a hydrocarbon having 2 carbon atoms and triple covalent bond, the name of the hydrocarbon will be ethyne. Let's see some examples to understand this. Look at this table. Here, the formulae and structures of saturated hydrocarbons are given. If there is only one carbon atom, then the prefix is meth, and if it consists single covalent bonds, then suffix will be ane. So this hydrocarbon is methane. It is represented by structure as one carbon bonded with 4 hydrogens with single covalent bond. So its molecular formula will be CH4. Similarly, if there are 2 carbon atoms, then what will be the prefix? Eth. And if there is a suffix ane, that indicates it is a alkane. So there is a carbon to carbon single covalent bond. Then you will find that as carbon has tetravalency, each of the carbon is bonded with 4 covalent bonds. So 2 carbon atoms bonded with 6 hydrogen atoms. So it gives the molecular formula C2H6. If the hydrocarbon contains 3 carbon atoms, then what will be the prefix? Yes, it is prop. And if it is the alkanes family, then the suffix will be ane. Then it is propane. So it contains 3 carbon atoms, and 3 carbon atoms are linked with the single covalent bonds. So these 3 carbon atoms are surrounded by 8 hydrogen atoms. So its formula is C3H8. Now, if the hydrocarbon has 4 carbon atoms in it, then the prefix will be but. And as it belongs to the saturated hydrocarbon, the suffix will be ane. So the carbon compound is butane. How will you draw the structure of butane? As but indicates, there are 4 carbon atoms. Suffix indicate ane. So what type of bond is there? Yes, it is single covalent bond. Now the work becomes easier. Show the tetravalency of each carbon atom by drawing 4 lines around each carbon and attach them with the hydrogen atoms. Then from this structure you will get the chemical formula as C4 and H10. So butane is C4H10. Now you will be given pentane. Then can you guess how many carbon atoms from this name? Pent. This pent indicates it contains 5 carbon atoms. The suffix ane indicates there is a single covalent bond between the carbon atoms. Then let us see the structure of pentane. First draw 5 carbon atoms and join them with a single covalent bond. According to the tetravalency rule, each carbon atom has 4 valencies around it, which are linked with the hydrogen atoms. So the molecular formula will become C5H12 pentane. And last example, hexane. In hexane, the prefix hex shows that there are 6 carbon atoms, and the suffix ane indicates it belongs to the alkanes family having single covalent bond. So first write its structure. Hex means 6 carbon atoms, ane means single covalent bond, and then according to tetravalency rule attach hydrogen atoms around the carbon atoms. So it will give C6H14 hexane. Now let us see these rules of writing the chemical formula and structure of a hydrocarbon by comparing between the examples of alkane, alkene and alkynes. Let's take example of alkane, methane. Now look at the name carefully. Methane. Meth shows that there is a 1 carbon atom, and ane shows it is alkane family member. So we can write methane and its information like this. Prefix meth, number of carbon atom 1, suffix ane indicates it belongs to the family of alkane, which has single bond between them. Now it is easy to draw the structure for this. What will you do first? First you have to write C and show its tetravalency. Now remember, there is a single covalent bond around each carbon. So 4 hydrogen atoms are linked with carbon, and it will give us the formula for methane. Now let's see the example of alkene family. Example given is propene. Now if you split the name, you will get the prefix and suffix. Prop, prop indicates there are 3 carbon atoms, and suffix ene tells it is a member of alkene family having carbon to carbon double covalent bond. So how will you write the information about this propene? Prefix is prop, means it contains 3 carbon atoms. The suffix is ene, which tells us that it belongs to alkene family alkenes have carbon to carbon double covalent bond between them. So let us draw the structure of propene. First we have to draw 3 carbon atoms and show a double covalent bond between any 2 carbon atoms. Then remaining carbon atoms and hydrogen atoms will be connected by single covalent bonds, taking care that each carbon atom shows tetravalency. So you will find that every carbon atom is surrounded by 4 lines. So it is tetravalent. So the structure of propene is C3H6. Now let us study family. The example given is butane. By this name, can you write the information about this prefix and suffix? But shows that it has 4 carbon atoms, and the suffix -ine tells us it belongs to Alkynes family, which has carbon to carbon triple covalent bond. So how will you write the information for this? Butane. The prefix but has number of 4 carbon atoms. Suffix -ine tells us it is the alkyne family member, which has triple covalent bond. Now let us draw the structure for butane. So how many carbon atoms? There are 4 carbon atoms. Then first show a triple covalent bond in between any of the 2 carbon atoms. Remaining carbon atoms are connected with the single covalent bonds. Now take care that each carbon satisfies tetravalency. So 4 lines are present around each carbon atoms. Now you can attach the hydrogen atoms to the empty space in these valencies. So you will get C4H6 as the formula. So this is butane. Now that you have learned the rules of writing the names of the hydrocarbons and the concept of prefix and suffix, let us practice to write the structure and formula of some hydrocarbons. Example 1. Draw a structure of methane molecule. Methane. So chemical formula of methane is CH4. Now from this molecular formula and this name, can you draw the structure of methane? First see what is the prefix and suffix. Meth indicates that there is 1 carbon atom, and the suffix "ane" tells that it is alkane family. So carbon is bonded with 4 single covalent bonds. So you have to draw first carbon atom 1, and it has single covalent bond around it. Carbon has valency of 4. So these 4 bonds are connected with the hydrogens. So you will get the structural formula of methane like this. Carbon is connected with single covalent bonds with hydrogen atoms, CH4. Let's take one more example. Draw a structure of ethene molecule. Ethene. So what is the formula of ethene? C2H4. Now what is the prefix? Eth. That is 2 carbon atoms. And what is the suffix? "ene", which helps us to understand it is the alkene family having double covalent bond. So its general formula is CnH2n. So you can get the number of hydrogen atoms if you substitute 2 carbon atoms in this formula. So CnH2n, that is C2H2 into 2. Simplifying this, you get C2H4. Now from this, you can draw the structure of ethene. So first, you need to draw 2 carbon atoms. Then, as per the suffix "ene", 2 carbon atoms are linked with the double covalent bond. Now check that there are 4 lines around each carbon. So 2 lines are used for double covalent bonding. Then remaining two lines will be used to attach with the hydrogen. So what is the molecular formula of the ethene? It is C2H4 and the structure is like this. Now let us draw the structure of cyclohexane molecule. Now don't get afraid. Cyclo means it is a ring structure, closed hydrocarbon. Hex means 6 carbon atoms and ane indicates that it is alkane having single covalent bond. So let's try this out. Some carbon compounds have carbon atoms arranged in the form of a ring. So cyclohexane. So first cyclohexane has the formula C6H12. Cyclo means ring structure, hex means 6 carbon atoms and ane means it is alkane having carbon to carbon single bond. Now from this information, can you draw the structure for cyclohexane? Yes. Remember that it is a closed ring structure. So show 6 carbon atoms in the form of a hexagon. Now as it is an alkane, so show there is a single covalent bond between these 6 carbon atoms. Now think of the valency. One atom should have 4 valency indicated by 4 lines. Now if you show 4 lines appropriately around each carbon atom, then you can join 2 hydrogen atoms with each carbon atom. By this, you will get the structure of cyclohexane. Now does it satisfies the molecular formula C6H12? Yes. C6H12. This is the structure of cyclohexane molecule. So in this session we have studied about the classification of hydrocarbons as alkanes, alkenes and alkynes. Alkanes are saturated hydrocarbons while alkenes and alkynes are unsaturated hydrocarbons. You also have studied how to write the structure and how to identify the molecular formula of a hydrocarbon by its prefix and suffix. So practice this and learn more structures and molecular formulae of hydrocarbons. Thank you.